most of us probably never heard about it previously, or might have just heard some passing references to this particular library, which is the TransactSql.ScriptDom parser. And the metaphor which we picked for the session title is the Swiss knife, and by the end of this session it should be fairly apparent to each one of us why we picked that metaphor, because it's like a multi-utility toolkit which we have been provided by the product team. So once again, welcome and thank you for taking the time and filling up the room so quickly. I just begin by quickly introducing myself and then getting on into the actual session. Let me just advance the slide. Yeah, there it is. So my name is Arvind. I work with Microsoft, and I'm part of a team called the Premier Field Engineering Team. It's actually part of the services organization within Microsoft, and I'm based in Mumbai in India. So it's actually quite late in the evening for me, and while it's really early for many of you up in the States. So that's the way the world works, right? So you can get in touch with me through Twitter or through my blog. I will put these up again towards the end of the session just for your recap. And the reason I wanted to do this session is what we found was when we worked with customers who ask us questions and ask for our advice on various topics related to SQL Server. Many of them have questions around things like T-SQL anti-patterns. How do you avoid coding particular patterns in SQL which don't perform well, etc. And they also have questions around specific needs related to T-SQL code. I'll show you some of those patterns in a minute. But really speaking, this session is it's been driven by the needs of the customers out there, just like each one of you. And my hope is to spread some of the knowledge around this beautiful piece of engineering, which is the TransactSql parser. So with that, I just want to set up the need, why the product team came out with this parser. And if you think about it, we have again a metaphor here in terms of the necessity being the mother of invention. I think we've all heard that phrase, and it's the same story with this parser as well. What I've shown on this slide is a couple of those use cases and a couple of those questions which we have faced from customers from time to time. A classic example is things like, let's say you have in your code you spotted certain let's say code patterns where you have a like predicate which has a leading wildcard in it, so like a percent at the leading edge of the literal. And let's say you figured that you've got around 400 stored procedures. You want to find out each occurrence of that particular pattern. You could do that by hand, but it's probably not going to be an easy ride. And you could do it using things like string manipulation, like finding a substring or something of that sort, but it's not an efficient or scientific way to do that. The second use case I have on this slide is again a very real one, and it comes from a case where we had a customer who wanted to drop some unused indexes, and they tried to drop some of those, and they quickly found that they couldn't really do that because they had indexed hints all over that code. So in that kind of situation, what happens is you're again running into this problem where I need to look at my code, and the code, let's say it's a huge code base, and I want to find out in a foolproof manner all occurrences of an index hint. So these are genuine needs which we've seen in various customer situations. The third one, again, this came up on Twitter on the SQL help hashtag. There was a person who asked if there's a scientific way of counting how many deletes they had in their code. And though it may sound like a trivial need, it's actually quite hard to do that if you think about it, right, in a scientific way, especially if you have a huge code base. Then the fourth one is from the client side. Let's say you have client code which is concatenating stuff, and you suspect that it's vulnerable to SQL injection. And though you've done some homework in terms of validating input and screening things at the web server, maybe you still want to do some kind of a validation by parsing the final statement before it's passed to the engine. And by doing that, you want to find out if there's anything other than just a select statement or maybe an execute procedure call which is being passed to the engine. I'm going to show you a demo on that particular application a little while later. And a final use case, which is again quite common, is formatting T-SQL. Right? You may want to have a homegrown pretty printer or a formatter for T-SQL. And a lot of these, this is just 5 simple use cases, and a lot of these would be things which you might have seen in your own work on a daily basis. So these are the needs which kind of drove us to develop some kind of a client or some kind of a consumable parser which can start looking at T-SQL and in a scientific way, not just based on some string manipulation or some regular expression based syntax. So just to compare the approaches which we have when you parse T-SQL, you could do it with your own homegrown string manipulation library, but that's probably vulnerable to things like false positives. We ran into this early on when we used some approaches around string manipulation, just using char index and substring, those kind of things. And we found that it was vulnerable to things like, let's say you have commented code, and let's say the pattern that you're looking for is actually within the comments. It might throw up a false positive, so you don't want those kind of false alarms to distract you. The second thing which you would face traditionally is stuff like compatibility levels. I'm sure most of you are aware of the fact that join syntax is, you have the non-ANSI join syntax, which was allowed in compat level 80, which was SQL 2000, and now you don't support that anymore in the engine, right? And that's just one change. And you have so many other changes. There may be statements which are actually added to the language. A classic example of this is the merge syntax. That's supported 2K8 and above, and you want to be able to parse that depending on the version of the server or at least the compatibility level of the database. The third challenge which you traditionally find is if you use the string manipulation technique, it's kind of hard to report back the exact line number and the column number. What you would probably end up with is an offset, because that's what a char index reports, for example. So a programmer though would obviously want to know which line of code is the problem on. So fidelity of the result is absolutely important, and that's a challenge we have to consider. And as I spoke earlier, scale in terms of let's say you have thousands of stored procedures in your code base. How can you do this kind of analysis efficiently? And last but not the least, if you do things like char index or use some other string manipulation technique on the server itself, you end up stressing the server, and that's probably the last thing you want to do, right? So it's obviously a need to be able to analyze code which is in a SQL script file, for example. At the same time, you want to have the flexibility to maybe consume stuff from a server as well. So these are some of the challenges that users who have attempted to write their own parser or their own solutions around these kind of challenges have faced in the past. So around the year 2008, and I'm hoping you guys can see my slides. I'm on a slide called the crown jewels now.
Yes, that's viewable.
Okay, thanks. Thank you. So this is a screenshot I captured from Gert Draper's blog. Gert actually is a program manager. He's still with Microsoft, but he's with another team right now. But in the year 2008, Gert Drapers, he's well-known representative from Microsoft, was the program manager who was instrumental in getting the ScriptDom parser out in the public. And we all owe a lot to him, in my opinion, because he was instrumental in getting this to a publicly consumable version. So Gert published this post, which I have a link to the presentation, to the post in my presentation deck as well. And there he described the first release of the parser, which was also called the ScriptDom parser, but it was implemented within a library which shipped with Visual Studio.NET, specifically the database project version of VS.NET 2008. The parser was also later shipped with VS 2010, and can you all hear me? I'm not on mute, so there was a comment saying.
Yes, we can hear you.
All right, it's Igor. I think it's probably maybe your speakers. So thanks for that. So the parser made its first appearance, if you may, in the year 2008 and thereabouts. And what we then evolved to was very quickly we found that there were certain sort of pieces which were common between the Visual Studio ScriptDom parser and another parser which actually shipped with Management Studio. Many of you know we introduced IntelliSense with SQL 2008 Management Studio, and that had its own limited parser. So there were two streams working in the product essentially, one which shipped with VS.NET and one which shipped with SSMS. And somewhere around SQL 2012 release, so I've just advanced a slide now, give it a minute to just refresh on your side. So roughly around calendar year 2012, we made available the ScriptDom as part of the SQL Server system itself. So this unified a lot of the work which was being done by the Visual Studio based ScriptDom and our IntelliSense parser as well. So the good news is now that's the version which we've standardized on, and this is continuing to be shipped both in the product and as part of the feature pack. The good news is also in SQL 2014 you will see an updated version of the parser for the syntax changes which have been made in 2014. But that's for a later release, right? So I just want to turn on my pointer options right here. So this is the namespace we are going to be dealing with, and I'm going to do a lot of demos. I'm not just going to talk today, I'll just show you a lot of stuff as well. And that's the namespace and the class which we're going to be using for our work today. So hopefully many of you would be comfortable with C# code, because this is mostly about coding, less about SQL than about coding actually today. And this was the old namespace right here. This is the one which shipped with the Visual Studio, just for your information. So the parser I am referring to, the TransactSql.ScriptDom parser, is a fully managed library, so it's like all .NET code. It doesn't use any unmanaged code pieces, which is good news because you have all the nuances of managed library out there. And it also ships in both 32-bit and 64-bit installs, which is again good considering that most of us are on 64-bit today, even on our desktops and laptops. So that's kind of the history and the way this parser has evolved. Today you can get hold of the parser, as I said, as a standalone as well through the SQL 2012 feature pack. I'm just linking to the SP1 version here because there were some minor updates between RTM and SP1 as well. And when you get onto that page, you want to look for the SQL DOM MSI file. So this is very important if you have an application which is actually using this parser. You don't need to install SQL Server completely. You just need to get this redistributable, this version of the parser, and you just install that MSI file on the application server proper. So that's quite significant if you're going to be investing in this parser for your applications itself. So that's just the basic logistics around where the parser came from and where you can get it. Let's dig into how you use it, and I'll follow this up with a demo very quickly. The namespace is huge, and if you take a look at the right hand side of my slide here, what I have is a screenshot from the MSDN library help, and this is just the snippet that I'm showing you is just the beginning. There's literally around 900 classes which are in that particular namespace. So it's very easy to get overwhelmed initially if you start browsing the help for this particular library. You might just get overwhelmed. So I wanted to break up the classes into certain units which you would find useful to begin with. The first one which we have here is the parser itself. This is the one which does the heavy lifting in terms of looking at your code. You feed it a string or a stream which contains code, and then it spits out what we call as a syntax tree for T-SQL. And we'll have a look at the demo which shows you exactly how that looks. Now you'll notice here that there are different versions of the parser, and there's one version for each of the compatibility levels, right from SQL 2000, that's compat level 80, all the way to SQL 2012, which is compat level 110. Now that's the first part. The second part is what I have here as T-SQL fragment. T-SQL fragment is actually what we call as an abstract class in C#. So it really doesn't exist in a sense. What we instead use that is, that's kind of the parent class for all the other classes that you see on the right hand side and that you will encounter in the real library itself. So you can think of this as the master class or as a fundamental base class for all the other classes which are exposed as T-SQL syntax elements. Later you will also see that it's quite kind of difficult to navigate the syntax tree without a little help, and that help comes in the form of this class called a fragment visitor. The fragment visitor is actually implementation of what's called the visitor pattern. It's a design pattern which allows you to kind of traverse and visit different types of nodes within the syntax tree. If that doesn't make sense to you right now, don't worry, I will show you how that works in a few minutes from now. And the last class, which is kind of a distinct thing on its own, is a script generator class. The name should be fairly obvious in terms of what this does. It's basically going to generate scripts. And this is one of those classes which you can use to kind of format T-SQL code. It's not just for formatting actually, it's got a lot more to do with generating like a snippet of code, but a quick thing you can use that for is to just format T-SQL code. I mentioned also that there's like 900 classes, and so what are those classes apart from these 4 which we talked about? Well, they're the individual statements or the individual elements of the language which we have. So for example, the select statement which you write in T-SQL is actually represented as a class which aptly enough is called select statement. Delete statement should be obvious enough. And then you have other things like this one, column reference expression. So column reference expression is used, that's a class in itself, and that's used to kind of represent any column which is encountered in your code. So let's say you wrote code which says select call 1 from tab 1, the call 1 portion of your code is actually represented as a column reference expression right there. Ditto for the table itself. So in the code that I talked about, wherein we're selecting a call 1 from tab 1, tab 1 would be represented by a class called named table reference, and so on and so forth. You have hundreds of classes. The most common ones are the ones I've put up in this slide, but literally there's quite a few which you will encounter in the real world. And the most important thing to keep in mind is that all of these classes are based on a very strong inheritance model. So it's all strongly typed, and you have a very strict hierarchy of inheritance which you will see in the demos that I have for you today. So this is kind of the basic stuff. And a quick note again about questions. We have allocated time towards the end for questions, so if you will bear with us, we'll just kind of get through the content, and I think we'll have enough time for questions at the end. So I just want to show you a quick demo now of ScriptDom parser itself. So let me just quickly shift to my VM, and let me just do that real quickly. We'll show you how easy it is to get started with this parser. So what I have here is a project in Visual Studio 2010. I'm just using the older versions to make you aware that this stuff works even with V version, which is not just the the blinding latest stuff. This is stuff which is probably 5 years old now, but it still works even on VS.NET 2010. So hopefully you can see my VM. Can you confirm that, Gabriel?
Yes, it looks good here on this end.
Thank you. So I have a very simple console application here, and I've put in some template code just to make it easier for me during this demo. What we're going to do is we're going to parse a SQL script file, and the sample procedure that we're going to parse is actually this one from AdventureWorks. So it's the standard USP update employee hire info code, and as you can see, it's got an update statement. It's got some transaction handling code in there, and at the end there's some error logging code as well through a stored procedure, USP log error. So I'm going to build this up. The first part of the demo is just to get you to parse this particular file and this piece of code, and there's going to be a later demo after this wherein we're going to try to isolate this particular line, which is executing another stored proc. Okay, so just watch out for that. It's coming up in the next demo. So we've got this template code here. It's fairly simple. It uses a text reader to open up this file, and then what we're going to do is we're going to actually instantiate our T-SQL parser and consume the script from the file. So the way you do that is, the first thing you need to do is to add a reference in your Visual Studio project. So I'm going to just browse to the location that you can find the parser, and I'll zoom in once I get to the location so that you know exactly where it is. So this one is under a folder which is within your SQL Server installation, and that's the one we are interested in, right? So this is actually within the program files for SQL Server. Look under that for the 110 folder, which is for SQL 2012. Under that you have an SDK, and under that you have the assemblies folder, which is where you find our parser right here. All right, so we're going to just reference that, and once that is done, we add a namespace declaration right here. So you'll just go ahead and take a look. So this goes under the Microsoft SQL Server TransactSql.ScriptDom namespace, right? So once you do that, you'll notice a couple of other errors which were highlighted earlier have gone away because I had pre-populated some of those for this demo. So let's instantiate the parser and consume our script, right? So the way you do this is you instantiate a parser appropriate for your code base. In our code, it's all SQL 2012 or compat level 110 code. So I'm just going to use the 110 parser. You have different versions of the parser, as I mentioned earlier, and what I'm going to do is just instantiate a new parser, and it asks you whether you want to have quoted identifiers on or off. By default, I always provide true because that is the default setting for most T-SQL code. Generally, you'd never need to set that to false unless you're using double quotes as quoted identifier. And then the code looks very simple. You just say parser.parse. There are other functions. We'll not go into that for the reasons of time, but this is the most important one that you would want to use for your practical day-to-day use. And you'll notice that it also allows you to retrieve a list of errors. So in this case, we're just going to use the pre-populated list which I have set up for this demo, which is a list of parse error right here, and that's the one which is going to contain any parsing errors which which are an outcome of using this particular snippet of code that we have. And pretty much at this stage, that's all that you need. The important thing to keep in mind though is where do we store the result of the parser. So if you look at the method, if you look at this here, it's going to return to you a fragment. And if you recall from the slide which I showed you earlier, the fragment is kind of the base class from which we derive our work. So I'm just going to quickly, in the interest of time, just show you. We'll just declare a fragment, and let's call that as the tree, because that is the parse tree for our purposes. And we'll put a little breakpoint at the end of the code, and we'll let this run. So at this stage, what's going to happen is it's pretty much going to parse through your T-SQL code and then generate a fragment. Now, I'm just kind of skipping ahead of time in a way, but let's say we add a watch for this tree, and if you zoom in here, I know it's a little tiny, hopefully you can see this, you'll see that the fragment is actually of a type called T-SQL script. So remember I told you about the fact that the fragment is like an abstract class, and this is precisely an example of what I meant by that, because what you ended up parsing is actually a script, and script is actually derived from fragment. So that's how it works. And if you zoom in even further on this, you'll start seeing a couple of other details. So you will see here that it's a script. You have some fairly useful details like what's the start column and what's the start line for this code. Obviously, because it's the whole script, it reports the start line and the start column as a column line and column 1. So we'll show you more of that later on in the subsequent demos, but hopefully this gives you an idea of how easy it is to use this stuff. You don't need to go through a lot of hoops just to get started. Okay, so that ends my first demo. It's very simple, as I said, and we will go back a bit to my slides and come back again to what you saw earlier. So I've switched back to my presentation now. Give it a minute to refresh on your side. So you already saw a preview of what's up on this slide, which is the syntax tree. The value which is returned by the parse method is actually a syntax tree. Technically, you would call it an AST, an abstract syntax tree, because it just depicts the way your code is without any particular bindings to the schema of your database, for example. This is just reflecting the syntax. So when you looked at the debugger watch window in my previous demo, you would have noticed it said T-SQL script, and I said that it is derived from fragment, and that's precisely what you see there. But this also causes a little bit of a challenge because of the inheritance model. If you just walk through the tree as is without any additional help, you'll quickly find yourself doing things like what's depicted on this particular slide. Let me just turn on my pointer again, and there we go. So if you look at this syntax, you'll notice that we're kind of casting. Casting is going to be almost essential if you don't have an alternate way of navigating through the tree, because everything otherwise is more or less a base class. So you'll notice here that the like predicate, for example, which is another class within the ScriptDom, it has many members, right? So if you want to look for the strings which are passed to the like predicate, which begin with a % wildcard, then essentially what you're going to be looking at is this thing called the second expression. That's a member of the like predicate. But the second expression is of type scalar expression. And scalar expression is actually, again, like an abstract class. It could be one of many types in reality. In this particular case, when you have a like % some value, for example, you end up having a very complex structure wherein you actually end up having to look for something called a string literal, which makes sense once you know it, but then how on earth are you going to know about it if if somebody didn't tell you? So this is one of the challenges that you will find when you're working with the ScriptDom, initially at least. I'll show you a couple of ways you can use to overcome this challenge. And the first technique you can use is this thing called the visitor pattern. The visitor pattern is actually a design pattern. It's a technique which is fairly common in programming circles, where you have something called a visitor. A visitor is nothing but a class. Again, you implement that class. And in our case, the visitors can be derived from two fundamental classes. One is this thing called the fragment visitor, which is actually a base class which allows you to visit any other derived class, including the base class itself. And then there's something called a concrete fragment visitor. So there's a slight difference between these two. I don't want to bother you with too much detail at this stage, but just keep in mind that the concrete fragment visitor actually just visits the derived classes. It doesn't visit any of the abstract classes. So in a way, it does make your life a little bit easier as compared to having to visit through all the abstract classes as well. And going along with these classes, you also have to implement something called a visit method. The visit method actually allows you to control what you want to do when you encounter a particular type of class. So this will make a lot more sense if I just show you a code snippet which uses the visitor pattern, right? So let me switch back again to my demo machine and discard those. Let me just switch quickly into the visitor pattern. All right, and this code actually builds on our previous code. Now, in the interest of time, I'm just going to pick up my solution for this and just kind of type it in, because I don't want to. I'm aware that we have around 22 minutes left total, so we don't want to do too much typing here. So I'm just going to use a bit of code which we've already typed in. So, and we're just creating a class which is derived from the T-SQL fragment visitor, which we saw earlier, right? So this is the first step you need to take to implement your visitor pattern. And therein you will see that I am implementing an override for an explicit visit. An explicit visit will actually take you directly to the derived class. And you remember the objective which I had talked about a few minutes ago? It said in the code I want to find out where am I having another execute statement. If you look at the code for a minute, you'll see that you have an execute statement right there. That's what you want to catch using your program. So that's what we're trying to implement right here. Okay, so the way this works is this class has to now be passed to your tree. You say, I want to visit my tree using this visitor class which I have just created. So the way you do that is, first of all, you use the tree. So you see this right here. So you have the tree, and you'll say dot accept, and you pass it an instance of your visitor. So we'll just play with the new visitor just like this. So essentially what you're doing is you have the parse tree or the syntax tree from your parse operation, and then you're just going to use this particular class to visit it. And for convenience, I'm going to put a breakpoint on the debug output which we have here. So we'll let that run, and you'll see quickly that it's actually come into the place where we have our breakpoint. So it's found out that you do have a type a statement of type execute statement right here. Now when you have this, again you will see some of the inheritance stuff coming in, and I'll make all these samples available, by the way, for you to look at offline. So this one right here, you'll see that we are trying to again typecast it. I mentioned earlier that you'll probably have to get used to typecasting, because that's the way this whole library is set up, because it's all abstract classes to begin with. But what we're doing here eventually is trying to get the procedure name which we're trying to invoke. So in our case, you remember we were invoking the USP log error. That's exactly what the program will now output. Okay, so that's pretty neat if you think about it, because now you're getting to understand your code without having to resort to any kind of a complex string manipulation or regular expressions or whatnot. So it's very powerful usage of this library. So let me get back to the slide. I've got a couple of more demos coming up. We'll just quickly skip through a little bit more. I'll probably bunch up demos in the interest of time. So the next thing I want to show you in this library is something called tokens. And to understand tokens, you need to go back to a little bit of theory. The parser you see as the ScriptDom parser is actually two things. There's something called a lexer. A lexer is something which recognizes syntax, and that emits something called tokens. Just to give you a very quick analogy or an example of tokens, the select keyword is a token. The from keyword is a token. The semicolons that you have are tokens, and so on and so forth. Right? So that's the first part which it internally handles. The second part is what you would mostly be interested in, which is the rules which say, okay, if you see a select and a from token in sequence, maybe what you're dealing with is a select statement. So based on that rule, it's then going to construct a class of type select statement. So this is basically what you get back in the form of something called a script token text. So this or the script token stream rather. The script token stream is very useful if you want to look at stuff which is not really represented by classes. Examples are things like semicolons, for example. So if this, just to give you a real world use case for this stuff, let's say you want to check in your code where exactly are you using single line comments, right? Because sometimes you may have a coding standard which says don't use single line comments, use multi-line comments. So you can get that kind of stuff from the script token stream. In my demo later, I will show you how you can use the script token stream to find out where in your code do you have semicolons, for example. So we'll do a demo on that later. I'm just going to skip to the next slide and come back. We'll bunch up two demos. The other things you can use the library with are things like PowerShell. So in my demos, I'm showing you almost exclusively Visual C# based demos, but you can actually use the library along with PowerShell. So on my blog, you have a couple of examples which show you how to use this library within PowerShell itself. The challenge you will find though is because PowerShell is somewhat of a simpler language than, let's say, C#. You cannot do things like the visitor pattern that I showed you right now. To do that, you have to implement a type within PowerShell, which gets a little bit more complex. So on my blog, there's a pretty good example of how you can do that in terms of using PowerShell and the visitor pattern together. So scripting or the script token text is one thing I will show you, and along with that, I'd also like to show you another demo about validating T-SQL. So remember up front when we were talking about the scenarios, I mentioned SQL injection as one of the possible scenarios. And let's say you want to have a check on does my code or does the code which is being parsed have anything other than select statements within it. So that's a possible way to detect an injection attempt, for example. And that's very easy to use. That's very easy to achieve using the ScriptDom parser and the visitor pattern. So let's go back to the demo machine and take a look at two demos back to back. One where we deal with the script tokens, and the second one where we deal with validating T-SQL. So I'm going to show you the first one, which is the token example, and that's quite easy to understand once you see the code. I don't have to do any typing on this one. I've already got it ready for you. So what we're doing here is, again, we're using the same, we're building on the same sample in this case. So we are parsing the stored procedure, which we started off with, and then we are using a tree, which is the actual syntax tree. And then we have a walkthrough of the structure using the accept the keyword. So that's basically the visitor pattern which you saw earlier, right? So this is the same visitor which we had designed earlier with a slight change. What we're doing this time is we're not just printing the name of the stored procedure which we're calling, but we're actually looping through the text. So each of the nodes, each of the T-SQL fragment derived classes have a token index, a set of token indexes. So these actually allow you to detect which tokens am I associated with. So we're going to set a breakpoint at a line where we are going to examine if our token is actually of type semicolon, and based on that you can actually take a decision. Okay, this is a semicolon, so I want to do something about it. In our case right now we're just printing it out. So if you run this, you'll see that it eventually gets into the section where we had our breakpoint, and at this time I want to spend a minute to just show you the structure of this token stream itself. So when I zoom into that, you will see exactly what I mean. Just let me work this a bit. All right, so what you have here is an individual token. So this one is an indexed one, so it's a specific token, and you'll see that the token has two attributes which are of quite a lot of interest to you. One is the type and one is the text itself. So that's the way you can use the script token array, so to speak, to kind of walk through what's inside the code. And as I mentioned earlier, this can have a lot of positive applications in things like, let's say, is my code delimited with a semicolon, for example. You could run some kind of a rule to detect whether your code complies with some coding standards around things like comments, etc. So hopefully that makes it easier to understand what I was talking about when I referred to tokens. The second example I want to show you at this point in time is the example around validation. And I have a very simple example here, which again is a WinForms application. This is to make it simple to understand. And the form accepts text, right? So we've got free form text entry here, and when we press the button, what the code is going to do is, again, it uses this visitor pattern. It's going to basically check if my code contains only select statements. And the way we've implemented this is quite simple. Our visitor class has a boolean which is defaulted to true, and the visitor actually has a check to see if we have a node which is actually anything other than a select statement. So this is kind of the reverse of your traditional of the previous code base which I showed you, and you'll also notice here I'm using the visit. The visit is for visiting abstract classes as well, and in this case I'm visiting an abstract class which is of type T-SQL statement. So all these other statements like select, insert, update, delete, for example, all DML statements, all of those derive from T-SQL statement. By therefore flagging any other type of statement other than the select statement, I achieve my requirement. All right. So if you run this, you'll see what I mean. So let's say we start off with doing a very simple query, which is select star from tab 1. So this is just a select. So it says it's okay. But the minute I do something else to this, which says drop table, my table, and you'll see that the visitor detects that there's something other than selects in it. So it's very, very trivial to achieve these kind of requirements with the parser, and this is a really useful check, in my opinion, for further validating your code if it's safe and if it's not vulnerable to injection, for example. Hey, thanks Mike for the comment. So this is really cool stuff, and I really wanted to show you how you can practically use the parser in your client code as well. Apart from that, there's other minor use cases. Sometimes it may be really useful as well. Things like formatting. I've already talked about this earlier. I'll just quickly recap on what I mentioned earlier. The script generator class is the basis for constructing T-SQL, and what that does is it takes a list of tokens. So if you've understood tokens from the previous demo, you know exactly what I'm talking about. And what it does is it then takes those tokens in and constructs a nicely formatted T-SQL statement. The generator also has lots of options for you to override. Things like, do you want this selects on a new line, so on and so forth. So it's very, very powerful. Again, I'll just do a very quick demo of this, and then we'll stop for questions. Let's go back to the demo machine, and again, in the interest of time, I'm just going to pick up the code so that we don't have to type too much, and let me just walk you through what we've done here. So let's zoom in, and here's the body of the code. Again, this is a WinForms app, so I'm taking an input from a text box, and the rest of the code should be fairly familiar to you by now in terms of the parse method. But here's where it gets interesting. So we start by instantiating a script generator instance, and all you need to do is call a generate script on it, and then what we're doing is we're pumping that output into another text box on our WinForms application. So if you run this again, you'll see exactly what I mean. So let's put in some really badly formatted code right here, my tab, and let's say I also follow it up with another insert statement. Insert my tab, say I values 1. So what you're seeing here is the power of the formatter again, or the script generator. So again, you just pump that in, and it's going to give you back neatly formatted, validated T-SQL with a semicolon appended to it, which is quite interesting, because I hope a lot of you probably know about this. I hope you know that we are highly recommending that you delimit your statements. It's not going to stop working if you don't use the semicolon, but that's something which we might mandate somewhere down the line. So stuff like this can be quite useful for you. But one thing I want to caution you about is with respect to comments. So if you put in a comment, you'll see that the formatted output doesn't have the comment, and that's intentional because the comment is not treated as a part of the AST per se, the syntax tree. So that's something for you to keep in mind. Again, on my blog, I have an example which is a little bit more robust than the one I showed you here. But to answer Mike's question really quickly, the formatting, the syntax highlighting is out of scope for our library here. One would have to do that on our own pretty much. So all that this does is pretty much aligns it and puts new lines and semicolons in place. It doesn't really color code anything, because what you get back is a string. It's just plain old string, nothing more than that. So I want to pause at this stage. I just have one last slide, and then I'm going to skip a demo in the interest of time to keep time for questions. One thing I just recently posted on my blog is this thing called a T-SQL visualizer. This is pretty cool again, because one of the problems you will find very quickly once you start using the ScriptDom is to find out these nuances. For example, the fact that a string literal has to be used inside a like predicate, for example. So what this does, what this example does, and you'll find the whole source code on my blog, is it actually reflects the entire syntax tree as an XML document. So that's pretty powerful because it's almost like a debugger, like a watch window which renders your tree as an XML document. Very useful when you're debugging and developing things with the ScriptDom. So I'll skip this demo because it's already on my blog. You can take a good look at it offline. And I just want to conclude by sharing some practical considerations which we have learned over time working with this library. The first thing is about memory. And the thing is, when you use a parser of this sort, it does tend to be memory hungry. For example, if you parse a SQL script, which is somewhere around, let's say, 150 megabytes in size, and that's a fairly large script, but you will quickly find yourself using up, let's say, something close to 2 gigabytes of address space and therefore RAM. So my advice to you is be aware that this is memory hungry, so use reasonably sized chunks of T-SQL. You don't want to give it too much in one go because the memory footprint then increases quite rapidly. The second thing is about threading. So if you're going to be using this in some high performance application, the methods are single threaded, so you may have to implement some higher level parallelism on your own. And the third thing, which you probably seen when I was doing my demos, so I'm just going to quickly skip back to this. If you look at my screen right here on the right hand side, you'll see there's a bunch of exceptions which have been thrown, and these exceptions are actually they're kind of expected. So let me just zoom back again. So right here you'll see all these things right here. They're part of the parsing framework, and so don't get too worried. They are intentional and by design, but they can slow you down a little bit if you are using a debugger. So just be aware of those performance implications when you're debugging applications within VS.NET, because the parser will throw a lot of first chance exceptions. They're not bad exceptions though, it's just the way the thing works. So that's like in a nutshell what we could cover in an hour. I've got a lot more detail again on my blog. You can jump to it with this shortened URL, and you can always ping me on Twitter and through my blog as well. There's a contact me there's a contact me button on my blog as well. So I'll pause here for questions. I think we still have maybe around a couple of minutes, maybe not more than that, but just open it up for questions.
Right there. There's a question there on the chat board. If you can see that, Arvind.
Okay, let me just unshare my screen and go back there. Is it the one from Andre?
Yes.
Cutting out comments. Yeah. So Andre, on my blog, actually, there is a way I have shown about how do you use the underlying tokens in the script token stream to retain comments. So let me quickly show you where this is on my blog, because I know this is this would be an ask. So we've got a solution for it. It's just that the parser doesn't treat comments as part of the tree. So you have to work around it. So if you go to my blog, let me just share my screen again. I've got this formatter, and the formatter does retain script. So you can take a look at my blog for some tips on how to handle comments.
Yeah, that sounds great. You have another question there by Mike.
Let me scroll up a little bit. I'm zooming in, so I'll have to zoom out. Get back here. Yeah, I did talk about this in the duration of the talk. So printing RTF is out of scope for our parser, because what the parser generates is simple strings. There are community solutions out there which let you introduce syntax highlighting. So there's like text boxes, for example, which have syntax highlighting, and that's more of a client, thing than a parser functionality. So what we get back is just nicely formatted strings. So syntax highlighting has to be done by the visualizer, so to speak.
Mhm. Right, and there's one more. The question on the very bottom is, does the ScriptDom library read in XML as well as print it out?
I didn't quite understand the context, but not really. So, Mike, the input to the ScriptDom parser has to be a stream which contains T-SQL code. It does not allow you to read in XML of any sort. What I have on my blog though is a way to kind of convert T-SQL, the syntax tree at least, to XML for easier visualization. So hope that makes sense.
Great. It looks like there's no more questions there for you. But we really do, we really do appreciate it, Arvind. I'm sure we can get the recording up as soon as possible, and
cool.
And if you can share with us your slide deck and some code samples, I would be glad to put that online as well.
Cool. So if you don't mind, I'll put those on my blog, and you can put the recording on the Aptiv site so that we can link to each other.
That would be great.
Cool. So I'll put that up early next week, and again, thank you everyone for attending. I really appreciate your participation, and I hope I increase the awareness of this library, which I think is really useful and otherwise underutilized. So hopefully you be our evangelists to kind of tell the story about this library outside. Thank you.
Definitely. Thank you. And